Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0706, refers to the specific error of transmission range switch open in Honda Fit models from 2015 to 2020. This code indicates a malfunction related to the transmission range switch, an essential component of the vehicle's transmission system. The transmission range switch is responsible for sending information about the gear position to the Engine Control Unit, ECU, and the Powertrain Control Module, PCM. This information is necessary for the vehicle's operation, as it helps prevent the engine from starting in gears where it should not, such as reverse or drive. The transmission range switch is located on the transmission assembly itself, often near or at the perspective of the shift cable connection. Initially, a proper diagnosis must rule out any mechanical failures within the transmission, as this error is strictly electrical in nature. The transmission range switch plays a vital role by detecting the position of the gear shift lever, whether it's in park, P, reverse, R, neutral, N, drive, D, sports, or low. This information is crucial as it informs the vehicle's control systems about which gear is selected. The transmission range switch is situated on the exterior of the transmission assembly, connected directly to the shift cable. This component ensures that the appropriate signals are sent to the Engine Control Module, ECM, and the Powertrain Control Module, PCM, which are responsible for regulating various aspects of the engine and transmission based on gear selection. Thus, if this switch fails or experiences an open circuit, crucial functionalities, such as starting the vehicle in the wrong gear, are compromised, leading to safety and performance issues. The primary cause of DTC P0706 is an electrical circuit problem, highlighting a potential break in the signal between the transmission range switch and the PCM. Loose or corroded connections can disrupt the functioning of the range switch, preventing accurate signal relaying to the control modules. Additionally, the transmission range switch itself may be defective, which can happen due to wear and tear or manufacturing faults. It's essential to meticulously inspect the connections and wiring harnesses for any signs of wear or damage to ensure proper connectivity. Because this DTC is explicitly concerning electrical failures, mechanical problems within the transmission that obstruct the switch's operation will not be contributing factors. Common symptoms of DTC P0706 include an illuminated check engine light or transmission warning light on the dashboard. Drivers may also experience issues such as the vehicle failing to start when shifted into certain gears, especially in reverse or drive modes. Irregular shifting patterns may occur if the engine and transmission control modules cannot determine the correct gear position. Additionally, experiencing harsh or delayed gear engagement can also be a symptom due to improper signals from the transmission range switch. These symptoms not only affect the performance of the vehicle, but can also lead to safety concerns if the driver cannot operate the vehicle as intended. The first step in troubleshooting DTC P0706 involves verifying the adjustment of the shift cable. An incorrectly adjusted shift cable can lead to erroneous signals from the transmission range switch. After ensuring proper adjustment, the vehicle should be turned to the on mode, allowing the onboard diagnostic system to become active. Using the Honda Diagnostic System, HDS, compare the transmission range switch signal inputs to the specified values provided in the diagnostic table for each gear position. For instance, when in park P, the ATP switch should register on while the others remain off. If these signals align with the expected outputs, the system may be functioning correctly under current conditions. However, if they do not match, the failure condition must be examined further. In Step 2, the technician should once again verify the transmission range switch signals via the HDS while switching between gear positions. The outputs of ATP, ATR, ATN, ATD, ATS, and ATL switches need to be examined closely. Each switch should behave according to its defined state, as indicated in the diagnostic chart, where only one switch should indicate on for each specific gear position. If any signals show that all switches are off, despite being in a certain gear, focusing on recording the specific abnormalities is critical. This recorded data will be useful in subsequent checks to pinpoint malfunctions more accurately and address the signal discrepancies accordingly. Step 3 involves disconnecting the transmission range switch connector, specifically the 10P connector. The vehicle should be turned to the off mode before this disconnection. Once the connector is detached, use a jumper wire to connect the terminal that did not previously indicate on to the vehicle body ground. This step is crucial as it allows for testing the functionality of the range switch by creating a known good signal. After establishing the connection to ground, turn the vehicle to the on mode again and check the transmission range switch signal via the HDS. If the switch now indicates on, this signifies that the transmission range switch is indeed faulty and requires replacement. If the switch output remains unchanged, it confirms that the switch is functional and directs you to investigate further in the next troubleshooting step. For step 4, it is imperative to check for open wires along the circuit. Begin by turning the vehicle to the off mode and jump the SCS line with the HDS. Afterward, disconnect the PCM connectors and the transmission range switch connector. This creates a point of continuity testing between the relevant termination points. You will need to check the continuity between the corresponding terminal of the transmission range switch connector and the terminals on the PCM indicating off. Proper continuity must exist for the circuit to be considered in working order. Should continuity be present, the wiring is deemed sound, paving the way for either a software update or substitution of the PCM if needed. If continuity is absent, then there exists an unrepairable break somewhere along that wire path that must be identified and resolved. The last troubleshooting step involves a similar approach focused explicitly on verifying the PG3 wire. Start by turning the vehicle to the off mode and then disconnect the transmission range switch 10P connector. At this juncture, continuity must be inspected between test points based on the disconnected state of the range switch. You will check between terminal number 5 of the 10P connector and the vehicle body ground, which serves as PG3 wire reference. If continuity is confirmed, the PG3 wire itself is functioning correctly, indicating that the transmission range switch should be replaced. Conversely, if continuity is lacking, it signifies a poor connection either between the PG3 wire and the body ground or an issue related to poor grounding at G101, requiring further repairs. Upon completion of repairs and parts replacements indicated during the troubleshooting process for DTC P0706, it is crucial to perform a final verification of repairs. Start by clearing the codes present in the PCM and carrying out a test drive to evaluate the vehicle under varied driving conditions. Monitor the system for any signs of a recurring DTC, as this would indicate that further inspection or resolution is needed. Additionally, it is essential to double-check that all signals from the transmission range switch are now functioning correctly per specifications. Confirming these successful repairs ensures that the vehicle will not only perform effectively, but also operate safely, giving the driver confidence that the issue has been resolved. Preventive maintenance can significantly lessen the likelihood of DTC P0706 recurring in Honda Fit models. One essential aspect of maintenance is conducting regular inspections of all electrical connectors, particularly those associated with the transmission range switch and PCM. Keeping these connections clean and free of corrosion will enhance connectivity and improve reliability. Avoiding moisture exposure by ensuring that seals are intact can reduce the chances of electrical issues arising due to water ingress. Additionally, staying up to date with routine software updates for the PCM is vital, as these often contain important fixes for potential glitches that could lead to illogical signal reporting from components. An overall proactive approach to vehicle maintenance can improve long-term health and reliability, reducing unexpected failures. In conclusion, DTC P0706 is an error that emphasizes the importance of the electrical connection and signaling from the transmission range switch to the PCM. Diagnosing this issue requires careful and systematic steps to ensure that both the switch and its connections are functioning correctly. Understanding that this particular DTC points solely to electrical faults excludes mechanical issues from consideration. Each troubleshooting step must be executed thoroughly to confirm whether the problem is a defective switch, loose connections, or wiring issues. Following through with the final repair verification and regular preventive maintenance will ensure that your Honda Fit remains performing at its best and free from complications related to this DTC. Please like and subscribe to the channel. See you next time.